discussing about the application of the series combination of cells. What is the application of the series combination of cells? The first one, if two cells, see how many cells are taken by the, if two cells of different of different EMF, different EMF are in series, then we can find out its EMF and resistance and the current in a circuit. So before we see the series combination, the all cells having the same EMF. But here the first condition was if two cells of different EMF. See, this is the circuit diagram. This is the first cell of EMF E1 and the second cell of EMF is E2. Is connected across the back resistance. External resistance is the R and its internal resistance is small r and its internal resistance also small r. Now it is considered by the R1, it is considered the R2, positive terminal and negative terminal, positive terminal and negative terminal. Therefore, effective EMF, effective EMF, effective EMF, E effective is equal. See the how many cells are different of cells, we write the E1 plus E2 and therefore effective resistance, effective internal resistance, effective internal resistance, effective internal resistance, that is the small r effect is equal to small r1 plus small r2, small r1 plus small r2. Therefore current in circuit, the current I is equal, what is the formula is there? Total EMF by total resistance. Total EMF by total resistance. Here say the total EMF. Total EMF how much is there here? The E1 plus E2 by total resistance. External resistance plus internal resistance. That is the Kepler plus small R1 plus small R2. See, this is the current in a circuit. If two cells of different EMF. Now the second case here. In second case, see here, if one of cell the reversely connected, if one of cell reversely connected, then effective EMF, effective EMF. See, what is the in 2 1, the one is connected by reversely. The reversely is nothing but, see, this is the first one. EMF is the E1 and positive and negative. Its internal resistance is the R1. Here is connected by the negative is connected to a positive. Negative is connected to a positive. So the negative and positive. Its EMF is E2 are connected through a external resistance is the R. Then find out its effective resistance and effective internal resistance and current in a circuit. See right here the therefore effective EMF, that is a EMF is effective EMF is equal E1 minus E2. The wrongly, see this is nothing but one is connected by the reversally. The reversally is nothing but see the minus. Then next effective internal resistance. See, this is the R effect is equal to R1 plus R2. But internal resistance, there is no change. It will be the same. Then the current in a circuit. I is equal total EMF by total resistance. Total EMF by total resistance. Now here the total EMF. Total EMF is equal to how much is there here? The E1 minus E2 by total resistance, the external resistance plus R plus R1 plus R2. This is the current in a circuit when one cell is the reversely connected. Here, the next we discussing the topic is parallel combination of cells. The before we see the series combination, now we discussing about the parallel combination cells. See, let us consider the n identical cells are connected in parallel. See, this is the n identical cells are connected in a parallel. See, this is consider the each EMF is E. Each EMF is and so on. This is the nth cell. N cell. N cells are connected. Now it is all positive terminal is connected meet at the one point. All positive terminals are the meet at the one point. And all negative cells of A terminals are meet at the one point. So this is the one point can be meet. This is the A point and it is considered the B point. Now this A and B is across is connected by the external resistance. What is connected by this external resistance R. Now here the passing of the current is I through a resistance. Okay. Now it's the positive terminal. This is the negative. Positive, negative, positive, negative, positive, negative terminals are coming. Now the all positive terminals is coming by the current is I. This will be meet at the here point, and this is the negative terminals is coming. This is the direction of the current. This is the current. Now right, then find out the current in a circuit. The current we can find out the before we find out the EMF and internal resistance. So now right here, n identical cells are connected in parallel. So what is the n identical cells are connected in parallel. Across a resistor or resistance capital R. Resistance capital R. Therefore, the effective EMF. So either therefore effective EMF. See, in parallel combination, the potential difference will be same. Now its internal resistance is considered small r. Small r is the internal resistance. The each cell having the internal resistance of the small r. Now the effective EMF, that effective EMF is nothing but E effective is equal to E. That means the each cell of the EMF is there for the only for the E is taken by the. Therefore, effective internal resistance, effective internal. See 1 by R effect. See this is the in parallel combination which taken by the series. This 1 by R effect is equal to 1 by R plus 1 by R plus 1 by R plus and so on n cells. How many cells are there? The n cells are there. There is the n times r n cells. That is equal n by r. That is equal how much is there? N by r. This is the 1 by r effect. Then r effect is equal to r by n. R by n. Therefore, the current in a circuit. What is the formula for the current? The current is equal to total EMF by total resistance. Then we can write here the total EMF. Now the battery of EMF, the total EMF is how much is there here? The E by total resistance. Total is external resistance and the effect of the internal resistance R plus small r by n. See, this is the current in a parallel combination of cell. Now again we have the two conditions are there. There is a special cases. Now the case 1. If the capital R is greater than not small r. What is that? The capital R is greater than of small r. There is a external resistance very large. The compared to the internal resistance. That means the internal resistance value can be negligible. The current in a circuit E by capital R. How much is this? E by capital R. Now the case 2. In case 2 we say if the internal resistance is greater than of external resistance. That means external resistance value can be negligible. The remaining what is the term is there here? I is equal E by R by N. The denominator of the denominator take the numerator, that is equal to N into E by small r. See, this is the formula of A. When internal resistance is greater than of external resistance. That the current in a circuit I is equal to N into E by small r. If external resistance is greater than that current in a circuit I is equal to E by R. This is the formulas of in a parallel combination of cells.